And we're going to look at some formulas that you can use when answering probability questions. Now, what I've got here is a Venn diagram, and I've just labelled the probabilities X, Y, and Z, and W in these four regions. So Y is the intercept of A and B, and X plus Y would be the probability of A, and Y plus Z would be the probability of B. So let's just write those down. So the intersection, we're going to allocate as the probability with the value Y. The probability of A would be X plus Y, and the probability of B would be Y plus Z. Now, if we looked at the union, everything inside A and B, we can also write that down in terms of X, Y, and Z. And that's almost the same as the probability of A plus the probability of B. But if you add the probability of A and the probability of B together, we get X plus Y plus Z, which is one Y more than the union. Okay, so the union is probability of A plus the probability of B, but we need to subtract a Y, so we need to take off the intersection. Okay, just take a moment to convince yourself that that is true. That leads to what we call the addition rule. So the union of A and B is the probability of A plus the probability of B minus the intersection. The multiplication rule, that comes from our tree diagram, where we have here the probability of A occurring. And this is a conditional probability tree, whereby the probability of B occurring depends on A. So this would be the probability of B given A. And we know to work out the probability of A and B, that'd be the probability of A times the probability of B given A. Okay, and that's where we get what we call the multiplication rule from. Okay, let's answer some questions. Here we've got two events A and B, where the probability of A is 0.6, the probability of B is 0.7, and we have the union as well. And we're trying to work out the intersection. So let's use the addition rule to start with. Just write that down. And we can rearrange this for the intersection. Okay, so I've just moved this last term over onto the left-hand side and moved that union term over onto the right. And now we can put in some values, because the probability of A is 0.6, probability of B is 0.7, and the union is 0.9. Okay, easy enough once you know the addition rule. For part B, we want the probability of not A. Well, that's even easier, because the probability of not A is 1 minus the probability of A. So we get the value of 0.4 as well. Okay, but now it gets a little bit more difficult. We have to try and work out the probability of not A together with B, not A union B. And I think at this point, I would just draw a Venn diagram. So I've got one here partly filled out. Now that we know the intersection, we can put that in. So that is 0.4. Okay, so that's the intersection of A and B. because the probability of A is 0.6, that means we have to have 0.2 here. And because the probability of B is 0.7, we would need a 0.3 in here. And if you add those together, you get a 0.9 in total, which means on the outside we have to have 0.1. Always remember to put that value in as well. Now for part C, we want to know what is the probability of not A union B. Switch back to black. So this means everything that's not in A together with everything that's in B. Okay, so everything that's not in A is everything on the outside of A. So that's that 0.3 plus 0.1. But together with everything inside of B, so we've got the union, so that means we need to include the bit inside of B as well. We've already got that 0.3, so we need to add the 0.41 as well. That gives us a value of 0.8. Okay, so that was part C. Part D, trying to work out the probability of not A intersection B. So where does not A intersect with B? So everything on the outside of A that intersects with B, hopefully you can see it's just this value here, 0.3. So quite easy. It's pretty straightforward just to use the addition rule. So just remember that one and then draw a Venn diagram to answer the rest of the questions. Okay, here's another one. This time we've got a conditional probability. So we've got the probability of C and the probability of D and the conditional probability of C given D. We could start off by just drawing a little tree diagram to represent this. So here's C, oops, and not C. And then, no, actually we'll start off with D, I think. So D, not D, C, and then we would have another branch here, not C. So the probability of C given D, that's this bit here, is 0.3. Probability of D occurring is 0.6. And then we can work out the probability of C and D if we wanted. Okay, let's just fill out these then. That would be 0.4, that would be 0.7. Now we want the probability of D given C. Now that's not on here. We can't work that out from the tree diagram because the tree diagram shows us the condition C following D. So how would we work out this one? Okay, so for this one, we're going to use the multiplication rule. Let's just write that out again. So probability of A and B is the probability of A times the probability of B given A. So we're just going to adapt that in terms of C and D. So probability of D and C. Okay, so A is D and B is C. And we've got the probability of C given D. And we've got the probability of D, which is 0.6. The probability of C given D is 0.3. So that gives us the intersection of C and D is 0.18. Now, you should be aware that the probability of C and D is just the same thing as the probability of D and C. Okay, so they are exactly the same. It's the same intersection either way you say it. So that allows us to work out the first bit here, the probability of D given C. Okay, so I've just swapped these letters around here from this one, swapped C for D and so on. So the probability of C and D is the probability of C times the probability of D given C. That's what we're after, so let's rearrange it for that. And now we can put the values in that we know. We've got the intersection, so that's 0.18. And we're going to divide by the probability of C, which is 0.2. Okay, so we get a value of 0.9 for that probability. Okay, for the next bits, I think I would just draw a Venn diagram now. We have the intersection, and that's normally the key thing when you're trying to solve probability questions. So let's draw ourselves a Venn diagram. Okay, so we'll call this one C, this one D. The intersection is 0.18. We've got the probability of C is 0.2. So this bit here is 0.02 to make up a total of 0.2 for C. And probability of D is 0.6. So this is going to be 0.42, okay, because those two added together give us 0.6. And then if we add them all up together, take it away from 1, we get 0.38 for the outside bit. Okay, 0.6 plus 0.02 is 0.62. So take that away from 1, we get 0.38. Okay, let's answer the next bit here. So that was part A. So we want the intersection of not C and not D. So everything on the outside of C that intersects with everything on the outside of D. And that's just going to be this 0.38. And then the last question, where's the intersection of not C and D? Okay, well, not C is on the outside of C. Where does that intersect D? It's this 0.42. Okay, hopefully that made sense. Sorry, that was just B and C, not C and D. There. In this example, we've got the probability of A as 3/10 and the probability of B as 2/5 and the union as a half. So we can go ahead and try and work out the probability of B given A, but in order to do that, we need the intersection. So the first thing we're going to do is to use the addition rule. And we know what the union is. That's a half. Probability of A, 0.3. Probability of B is 0.4 minus the intersection, which is what we're after. Okay, so if you work that out, we get the intersection 0.7 minus 0.5 is 0.2. Okay, now we can work out the probability of B given A. So just rearranging this multiplication rule. Okay, it's this given bit that always goes on the bottom here. Okay, probability of B given A. Probability of A and B, or B and A, doesn't matter which way around you write it. The probability of A has to go on the bottom because that's the conditional part. So we get 2/3 or 0.6 reoccurring. Right, so that was first part A. Part B, let's do the same thing. We'd use the same rule, but now we're going to use not A instead of A. Okay, so the probability of B given not A. Okay, so that's the rule. That's the multiplication rule that would give us the probability of B given not A. We can work out the probability of not A quite easily, but what about the intersection of B and not A? I think at this point I would draw a Venn diagram. So let's go ahead and do that. Right, so we have the intersection, which is 0.2. And the probability of A is 0.3. So this bit here is going to be 0.1. Probability of B is 0.4, 4/5. So this is also 0.2. And in total, we get 0.5 for the outside bit. Okay, so the union is 0.5, which is correct. Right, so can we work out the intersection of B and not A? So this top value here. So where does B intersect with the outside of A? Not A, it's going to be 0.2. And the probability of not A, well, the probability of A is 0.3, so the probability of not A is 0.7. Okay, remember they have to add up to 1. So 2/7 as the probability of B given not A. Okay, the last bit here, we want the probability of A and the probability of B given not A. We've already worked them out. The probability of not A we know, the probability of B given not A we've just worked out. So let's put these values into C. So we have probability of A times the probability of B given A. Plus the probability of not A times the probability of B given not A. Okay, so probability of A is 0.3. Probability of B given not A, so probability of B given A, we've worked out as 2/3. Probability of not A is 0.7. Okay, so it's just 1 minus the probability of A. So 1 minus 3/10, or 0.3, 0.7. And then the last bit, the probability of B given not A. So that was 2/7 there. So we have 3/10 times 2/3 plus 7/10 times 2/7. Okay, well that's quite nice to simplify and work out. So 2/10 plus 2/10 is 4/10. Okay, and that was the answer to part C. It says comment on your answer to part C. Well, I'm going to let you guys have a little think about that. What would happen in general when we combine these two terms?